Welcome to another episode of SAT Q&A. Today I'm responding to a question from a member of Recent Prep about a particular Blue Book problem, and that's a problem from Test 1, Section 7, number 16. So let's check this one out. It's a grid-in. A four-digit integer, wxyz, in which w, x, y, and z each represent a different digit, is formed according to the following rules. What is the four-digit integer? So we have 10 choices, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 for each of these digits, and they've got to be different, so we obviously can't repeat. So we've got some rules here. We know that x, whatever the x is the sum of the other three digits, okay? W is going to be 1 more than y, and z is going to be w minus 5. So the key with this one is seeing the restrictions and looking at what the restrictions tell you are possible and then going from there. So for instance, this is the most important one to look at for now. Because for instance, can w be 0? Well, if w were 0, then z would be negative 5. So we know, just looking at this list, w cannot be 0. W can't be 1, because again, 1 minus 5 is negative 4. It can't be 2, can't be 3, can't be 4. But it can be 5, 6, 7, 8, or 9. Right? That's no problem. Okay, that's good. So let's go ahead and see what happens when we're limited to these as our w. So what happens if w is 9? Well, if w is 9, then y would equal 8, right, by this equation. And notice above, then x would have to be at least 9 plus 8, which is 17. That doesn't make any sense. X has got to be one of these digits. So for that reason, we can actually get rid of 9 for w. What about if w were 8? That would mean by the second equation, y would be 7. 8 plus 7 is 15. X can't be equal to 15, even though we got z here, right? I mean, that would just make it even bigger. So x can't be equal to 15, can't be a two-digit number, we can get rid of 8. How about 7, right? If z were 7, or excuse me, if w were 7, then y would have to be 6. And again, can't happen because 7 plus 6 is 13. Whoops, wrong one. 6 would make this one 5, right? 6 plus 5 is 11. X can't be 11. So the only one left is 5, right? So if w were 5, then y would have to be 4. And notice as well, if w were 5, here's y, w. If w were 5, then by this equation, z would have to be 0, which means x would be 5 plus 4 plus 0, which is 9. And there we go. So our number would be, w would be 5, x would be 9, y would be 4, and z would be 0. So that would be our final answer. So the key to this one, at least with this method, is to look at the restriction, see what possibilities you've got, and narrow down to the final answer based on a systematic appraisal of each one of the answers, each one of the possibilities. That's one way to do it. Another way is to actually make it an equation. So let's make a substitution into the top equation. So we have x equals w. Well, we know that w equals y plus 1. If we rearrange this, we'll get w minus 1 equals y. So let's make that substitution in here. So we get plus w minus 1. And we know that z is w minus 5, so we'll just make that substitution. And we get something like this, x equals w plus w minus 1, and so on. So finally, we get x is 3w minus 6. So what does this tell us? Again, test w's. Can w be 0? Well, that would be, means x would be 0 minus 6, negative 6. No good. Can w be 1? Again, 3 times 1 is 3. 3 minus 6 is negative. Can it be 2? No, yes, it could be 2 because you'd have x is 0. Could w be 3? Yeah, you'd have x is 3. Could you have, well, actually, we'll come back to that in a second. Could you have w is 4? Well, yeah, you'd have y is 6. Could you have w is 5? Yeah, you'd have y is 9. Could you have w is 6? Well, no, because then you'd have 18 minus 6, which is 12. So everything greater than 6 doesn't work. So our possibilities are 2 and 0, 3 and 3, 4 and 6, and 5 and 9. Notice 3 and 3 can't work because they can't be the same digit. And then we would just test these possibilities. So if w were 2, then y would have to, we would test out the z. That means, again, z would have to be negative 3, no good. If w were 4, z would be negative 1, no good. So the only one that works again is when w is 5, z's got to be 0, and then you move on from there. So again, different way of approaching it, but nonetheless, it's going to lead you to the same answer. Okay, so let me know if any of you have any other questions on this one, and I'll talk to you all later.